Hi everyone, my name is Camille JC Sasa. So for today's video, I'm going to have a tutorial video about chapter 5, which is discussing about Ethernet. So if you're interested in this video, please keep on watching. So let's proceed. The original Ethernet IEEE standards defines a minimum Ethernet frame size as 64 bytes and maximum of 1,518 bytes. The maximum was later increased to 1,522 bytes to allow for VLAN tagging. Ethernet operates in the data links layer and physical layer. Ethernet relies on the two separate sublayers of data link layer to operate a logical link control LLC and the max of layers. The max of layer has two primary responsibilities: the data encapsulation, media access control. Data encapsulation provides three primary functions, which is frame delimiting, addressing, and error detection, while the Ethernet frame has max sublayer. So, media control is responsible for replacement of frames on the frames from the media sublayer communication layer. The switch receives the Ethernet frame, examines the source MAC address, and notices that this MAC address is not in its MAC address table. So it adds that MAC address and incoming port numbers. Next, the switch examines the destination's MAC address and notices that this MAC address is not in this table, so it floods it all on ports. The computer receives the Ethernet frame, examines the destination MAC address, and against its own MAC address and notices that it is matched that receives the rest of the frame. There are two variants of cut-through switching: fast-forward, fragment-free switching. Fast-forward switching offers the lowest level of latency. The switch immediately forwards a packet after reading the destination's address. This is the most difficult form of cut-through switching. Fragment-free switching, in which the switch stores the first 64 bytes of the frame before forwarding. It is a compromise between store and forward and fast-forward switching. In an attempt to conserve bandwidth and not forward useless frames, Ethernet device drop frames that are considered to be rand less than 64 bytes or jumbo greater than 1,500 byte frames. The minimum Ethernet frame is 64 bytes. The maximum Ethernet frame is 1,518 bytes. A network technician must know the minimum and maximum frame size in order to recognize and jumbo frames. A MAC address is composed of 6 bytes. The first 3 bytes are used for vendor identification, and the last 3 bytes must be assigned a unique value within the same UI. MAC addresses are implemented in hardware. An NIC needs a MAC address to communicate over the LAN. The IE regulates the MAC addresses. A switch builds a MAC address table by inspecting an incoming layer 2 frames and recording the source MAC address found in the frame header. The discovered and recorded MAC address is then associated with the port. When the store and forward switching method is used, the switch receives the complete frame before forwarding it on the destination. The cyclic redundancy check, part of the trailer used to determine the frame, has been modified during the transit. In contrast, a cut-through switch forwards the frame once the destination layer 2 address is read. Two types of cut-through switching methods as fast-forward and fragment-free. Auto MDIX is a feature that is enabled on the latest Cisco switches and allows the switch to detect and use whatever type of cable is attached to a specific port. Buffering is a technique used by Ethernet switches to store frames until they can be transmitted with port-based buffering frames and stored in that are linked to specific incoming and outgoing ports. Let's proceed to the certain situation. So, refer to the exhibit or the picture. The exhibit shows a small switch network and the contents of the MAC address table of the switch. PC1 has sent a frame address to PC3. What will be the switch do with the frame? The MAC address of PC3 is not present on the MAC table of the switch because the switch does not know where to send the frame that is addressed the PC3. It will forward the frame to all the switch ports except for port 4 and which is incoming port. So proceed to the uh, next exhibit. Issues PC1 issues an ARP request because it needs to send a packet to PC2. In this scenario, what will happen next? When a network device wants to communicate with another device on the same network, it sends broadcast ARP request. In this case, the request will contain the address of PC2. Refer to the exhibit. The switches are in their default configuration host and needs to communicate with the host D, but host A does not have the MAC address for its default gateway, which network host will receive the ARP request sent by a host A. Since host A does not have the MAC address of the default gateway in its ARP table, host A send an ARP broadcast. The ARP broadcast will send on every device to a local network, host B, C, and Refer to the exhibit. Switches with the default configuration connects 4 hosts to the ARP table or host is shown. What happens when a host wants to send an IP packet to host D? Whenever the destination MAC address is not contained within the ARP table of the originating host, the host in the example will send a layer 2 broadcast that has destination's MAC address of all devices on the same network receives the broadcast with D respond with the broadcast. What is a destination MAC address on an Ethernet frame that is lives to the web server if the final destination is PC1? A destination MAC address is used for a local delivery of Ethernet frames. That MAC layer address changes each network segment along the path as the frame leaves the web server. It will be delivered by using the MAC address of the default gateway. So that's all for this chapter. I hope you learn more and I hope you stay tuned in my next video. Let's all learn together.